Everyone will start in next 2 to 3 minutes. Let others join, and then we can start with today's session. I think we are good to go. We can start with today's session. So, hello everyone. A very warm good morning, good evening, and good afternoon to all of you joining from different parts of the world for this internship program. My name is Akshay, and I have been associated with Programmers IO from the last 2 years. And in this internship program, till now, you have covered and gone through the different IBM commands, the different IBM keywords, how to manage the program flow, the file systems, and the SQL RPGL, how to integrate that within our program. From today, we'll start with a new topic that is display files. So let's get started. The agenda for today is that we'll see the introduction, the structure of the display file, the ways to create a display file, the different keywords that can be used within a display file, the types, then how we can use a display file in our program, and at last there is some topic for the command detention and command function keys. We'll learn about that. So first thing first, what are display files? Now consider that as a programmer, we want to add certain records to the database physical file. We have multiple options. Either we can use the system commands like upd run query, or we can use the SQL to add record. But now consider from a point of view of a user who does not know these commands and who is new to the system. How will he be able to learn these commands, or how will he be able to use the add the records into the file? For that, display files comes into the action. In very simple terms, display files are screens, or one can say the user interface that allows the interaction between a user and the program. It can also be considered as a front end of an application within an IBM machine. It will have layout, it will have different formats, it will have elements. We can design fields, buttons, and labels on top of it. Next is the purpose of display file. So sometimes in IBM application, the user has to some inputs, has to generate some outputs. And for that to happen, display file helps to provide a very interactive experience. So we can have inputs, different inputs, we can generate outputs, we can generate reports. So that can be done using a display file, and that will be more of an interactive way. Next, we'll see the structure of display files. So just don't get confused with these images. When we go to the practical part of designing a display file, we'll cover these images. For now, we'll see the structure. The very first is how we create a display file. We have to create a record, and each record will represent a different screen or a section of a screen. Then the next thing is the fields. So fields are basically interactive elements on which user can take the input, user can take the output, and on each screen we can have multiple fields, as many fields as we want, and it will have the attributes like length, data type, etc. Like in the image you can see D2ERR is a field, D2EMPID is a field, D2EMP name is a field, and their corresponding lengths are given. So this way we can design the fields. Next we have indicators and constants. So we can define indicators, and that will be useful to control the flow of the application or the behavior of the fields. So by behavior I mean that we can control how the different fields will work according to the indicators. At last, constants, or what we can call them labels, which will guide the user basically to for the fields, what exactly are the fields for, what are the headings. So constants are or labels are for that. So this was just a basic theoretical part for the display files. Now we'll see how we can create or design display files. So there are two ways to create or design a display file. One is using a command strsda, and the other way is just like we create a new member. So let's go to the practical aspect. So the first way to create a display file is strsda command. So if I press enter, there will be option to design screens, design menus, and if we want to test our display file. For now, we'll be designing a screen, so we can put option 1 and press enter. Then it will ask for the source file name, the library name, and the name of the display file which we want to create, or the name of the member. So we can give any name. I have given DSP03D, and if I press enter, this screen will be loaded. And here we can design the screen. And the other way to design a display file is we can press F6 for creating a new member. Then in the source member, we can give the name of the display file which we want to create. And in the source type, we have to give DSPF, that means display file, and then press enter. So it will give us a SEU editor. We do not need to do anything here. We just have to file it, and then it will be created like this. And if you can see, we have a option 17, change using SDA. So we can put option 17 in front of that, and the same screen will be loaded which was there using the str_sda command. Now, so we discussed, we first thing we need to create a record. So what we have to do, we have to write the option 1, and in the record we have to give the name for our screen. So let's say I give a name REC01. I press enter. It will ask me to give the type as well. So there are different types we can create. One is the record, which is basically a static screen where we can take inputs, generate outputs, and put in labels and everything. Then we have SFL, that is a subfile, which is a dynamic screen and which is basically used to load a data in tabular form. Then we have window. So by name, it is quite understandable that window is a small pop-up which will be shown in front of a screen record or a subfile. So window is there. Then we have SFL message and other types, which we'll discuss in further sessions. In this session, we'll only be considering the record and the window. So I have given type as record, and then if I press enter, this will be the screen where we'll be designing that. Now, this entire screen is not available for designing, so we need to be sure about where we are putting our variables and where we are putting our labels. To get that, you can see in the bottom right corner, there is a row column identity. So first row, second column. So we can move it to the left side. So this is the first place where we can start designing our screen. We have 24 rows. We can design it up to 24 rows. So if I go to the bottom, we have the 24th row where we can design it. And similarly, we have up to 80 characters we can design it. So if I go to the right side, it will have 80. Till this is the part of the screen where we can design actually the display files. Now, if now once we know that where to design, there are some inbuilt keywords which are used to define some important things in a display file. The very first one is we have to put star user and press enter. So this will be the name of the user, the who has logged into the system. This variable will have that name. Right now it is showing as you, but once you use that in a program, this will be automatically populated with the name of the user, and it will have a length of 10 characters. So this is a default length. So it will take 10 characters, and if the name is less than 10 characters, it will take those many characters. The second thing is we have a date and time keywords. For date, we can write star date, and it will be used in this format, and whatever the format of the system will be there, the date will be shown in that format. Similarly, for time, we have to write star time, and it will give us the time. So these were the three keywords that we can use and that are given provided by IBM. Then we can create labels or headings. For that, what we have to do, we have to write the heading or label in a single quote. For example, I have started with a single quote, and then I can give any label. Let's say I have given programmers.io. Then I have to close that with single quotes again and press enter. So this will be a constant field, and we can write as many fields in a line as we want. If I want to write something else, let's say internship. So we can again start with the single quote and end it with a single quote. So that will also be there. If I want to delete something, for example, I accidentally wrote something and I want to delete that. So we just have to write D in front of that like this and press enter. So that will be deleted. Now I want to move certain labels or fields from one position to another. For that, what we can do, if I want to, let's say, move programmers.io to the right side, so we can use the greater than sign like this until we want where we want to move that, those many greater than signs, and then press enter. So it will be moved to the left side. And similarly, if I want to move any label or field to the left side, we can use the smaller than sign and press enter. So it will be moved to those places. Then if I want to move it to some other line or some other place, then what we can do, we can write hyphen in front and hyphen at the end of the label. And wherever we want to move that, we can write equal to sign, and that will be moved to that place. Similarly, to copy that from one place to another, again we have to write hyphen at the end and at the beginning. And wherever we want to copy, we can use double equal to sign and press enter, so that variable or field or label will be copied to that place also. Right now I don't need the other one, so I am putting D in front of that and deleting it. Then there are some shortcuts. So let's say I want to move this programmers.io at the center. For that, what I can do, I can write A in front of it and then C, we can overlap the first alphabet with C like this and press enter. So it will be automatically be center aligned. So these are the how we create labels. Now the next thing is we discussed that we can create fields for input and output. So how we can do that? So let me create a label first so that it is understandable. So it is asking to input a number. So how we can create a numeric field? There are two types of fields which we can create, either a numeric type or a character or alphanumeric type. And in that we can have a only input mode field, an output mode field, or a field with both input and output mode. So first let us consider the numeric type. So if I just want a input field, for that I what I can do, I can write plus 3. 3 is for input numeric field, and inside the bracket we can write the length of that. Let's say I want to give 3 length, so I can write 3 in the bracket and press enter. So this will be a numeric field, input numeric field of length 3. You can see there is a negative sign as well, so that is just for we can enter negative values as well. Then if the user wants to create a output field, numeric output field, for that we can write plus 6, and inside the bracket parenthesis we can give the number of characters or the length for that numerical value like this. So it will be an output field, so user will not be able to put anything inside this. It will be automatically generated from the program. We can put in the value from the program and it will be populated, but it will not be able to change on the screen. The third one is both input and output, where the user can take the input as well as generate the output in the same field. For that, we have to write plus 9, and inside brackets again we can give in the length. This field is now a both input output field. So this were for the numeric data type. I can delete this. Now comes the alphanumeric data type. Let me give a label. So operation we have to given. So again there are three types. We can give either a input field, either a output field, or both. So to get a alphanumeric input field, we have to write plus I for input, and in the parenthesis we can give in the length. Let's say I'm giving 1. So this will be an input field. We can do this inside of instead of giving the length in the brackets, we can write it this way also. Plus I. That means it will have the 4 lengths. So that depends on our choice how we want to use it. It will work the same way. Then for the output only alphanumeric field, we can write plus O, and again in the parenthesis we can give the number of characters for that. Let's say I want to give 2. So this will be an output field of length 2. And similarly for both input and output, we can write plus B for both input output, and in the parenthesis again we can write whatever length we want to give. So this is the way we create input and output fields. Right now I do not want this, do not want this. Now we have created fields for input and output, this one and this one. Now the question will be, how will these fields be used inside our program? For that we need to name these fields. If I put question mark in front of it like this and press enter, in the bottom you can see there is a name coming, FLD001, which is the default name, FLD001, FLD002, so on and so forth. We can change this according to the whatever coding standards we are following in our organization. Let's say I'm giving it as D3 num1 for this field. So whenever I want to use this field in my program, so I will use the name D3 num1. And similarly for this, let me give something like this. So this will be D3 operation. So this way we can rename our fields and be able to use them in our program. Then there are some attributes which we can define or keywords which we can give. For that, we have to write asterisk in front of the label or the field. For example, if I put asterisk here and press enter, so it will give us the options to select different types of field keywords. There are display attributes, there are colors, there are keying options and other type of keywords. First, we'll see the display attributes. After pressing Y on the display attributes, we'll be given this screen, and there are certain options like high intensity, reverse image, column separators, blink, non-display, underline, position cursor, etc. So these are the attributes which we can use for our fields or labels. High intensity means the field will be highly intensified than the other fields. So if I want that, I will put Y in front of that keyword. For high intensity, if I want to use that, I'll put Y here, and the field will be intensified than the other fields. The reverse image is something like, I'll give a Y here and I'll show you how reverse image works. I have given reverse image as Y, so you can see that there is a background image coming for that. So this is applicable or useful when we want to tell the user that there is some error or some issue with the value on the screen. So you can recheck that. At that those cases we can use the reverse image. Again, I put asterisk and go to the display keywords. Then we have the blink column separators. Blink means the field will keep on blinking. Non-display is there will be certain cases where we do not want to display certain fields at some point. So for that we can put Y. If I put Y, so that in that field will not be displayable on the screen. Similarly, underline is if we want to underline that field, and position cursor is, you can see if I press tab key on my keyboard, the cursor is moving to the next input field. So if I put give Y in front of position cursor, then the cursor will automatically go to that field. And also in the right side, you can see there are options to put in indicators. Those are for, let's say, at only certain points you want to give these attributes. So if I give 50, 50 means indicator 50. So this means if the indicator 50 is turned on inside our program, then the reverse image will be turned on. And if the indicator 50 is off, then the reverse image will automatically be off. So indicators, as we discussed, controls the flow of the program and the behavior of the fields. Similarly, I can put another indicator for the position cursor. So when indicator 50 is turned on, 51 is turned on, then only the position cursor will to that field. Then there is one more concept to put in indicators, like the negative indicator. So N50, that is the opposite of 50. So if there was only 50, that means if indicator 50 is turned on, then only the reverse image will turn on. And if I give it like N50, so when the indicator 50 is off, then the reverse image will be turned on. Then we have colors, that these are basic. If we want to change the color of our field or variable, we can use the option 1 in front of that color. If I have given 1 in front of blue, so the field will change its color to blue. An indicator is of same purpose. If we want to control the behavior according to the indicators, then we can give the indicator as well. For now, I do not want that. I have just given 1, so the color will be automatically changed. There are some other keywords as well, like the mandatory entry, mandatory field, field exit key required. So these we can also put in for our display files. Mandatory entry means that whatever field we are putting the value in, we have to put something in that. Only then it will accept, otherwise it will throw an system error. Mandatory field is something similar to that, but there is a difference that we can put if the field length is 2 or 3, so we can have to put all the length characters, then only it will. So you can try all these and see how the functionality works, the indicators we can provide accordingly. And now you see we have put in colors, so there are some shortcuts as well to put in colors. Like say I am defining a function key at the bottom, F3 is equal to exit. And if I want to change the color of this, either I can put asterisk and then go to colors and change the color, or the other way is that I can put C in front of it and overlap the first character with the color name, like B for blue. So I can write B, so the color will be changed to blue. Similarly, for the other colors, we can do it. Right. So the indicators which we gave using the asterisk were the field level indicators. Now there is one more thing. I'll come out of this, and this is the screen which we have designed. If we want to see it again, we can press 12 in front of that and enter, and we can see whatever we have created. Then you can see there is a option of select keywords, option 8. So we can put option 8 to select the record level keywords, and we can go to indicators keyword, and here we can give indicators as in the some function keys which will be used to control the program where the display file will be used. And for that, you have seen that F3 or function key F3 is used to terminate the program. So for that, what we have to do, we have to write CA03, and then in the response we have to write 03, which will tell the display file or the program that the value of CA03 is when we press F3 function key, and in text we can give the text whatever we want. Just to make it understandable, I am giving exit so that whoever sees this display file, the DDS of the display file, he'll be able to understand what the key is for. Similarly, we can define other keys if we want to use a function key for refresh. So we can give a function key, and that it will be used for refresh. The action we have to control in the program, but we have to first define it. Only then we'll be able to use it. And then after creating, we can come out and we have to just compile this and it will be ready to use. So I have some display files already created. I'll show you that, and we'll see how we can integrate that with program. So these are two display files which I have already created. I'll show you them first. Again, 17, option 12 to C. So it looks similar to a simple calculator program. So this is a output field which I have created to put in the error, whatever error will be there. So I have controlled that in my program. I'll show you that also. Now we have designed a basic display file, and now we'll see how to integrate that with our program. So I'll go to the source file for the programs. This is the program which I have created. Now, if we for using the display files in our program, we have to first declare that, just like we do with the database files or physical files. So this is the way to declare that in the free format. DCLF, that means declare file, then the name of the display file, and then we have to write a keyword workstation. workstn. This is the way to declare it in a free format. And for the fixed format, we have to declare it on the f spec. I'll show you how. So we have to write f. We can write click F4, and in the file name we can write down the name of the display file. In file type we have to write C. C means both combined input output. We can press F1 and we can see what values we can put in. So sorry, here I have to put F1, and I can see C is indicating a combined input output file. So C, then the file designation will be a fully procedural file. File format will be an externally described file, and in the device we have to write the keyword work stn. So this is the way we can define it, declare a file in the fixed format. Right now I do not need this because I have already declared that in free format, so I'm deleting it. I'll debug this and show you how it is working. Okay, the source is not coming. For that I have to compile the program in source. For that I have to press F4, F10, go to the bottom and see debugging views. I can write source here, and now the source is available. I'll call that program. See the yes. So first I am running a subroutine which will turn off all the indicators. By all the indicators, I mean the indicators which I have given for the reverse image and position cursor. So I have four fields in my display file. The first number, for it I have turned off its indicator for reverse image. That means in the beginning the reverse image will not be shown. IN51 is for the operation field, that too I have turned off. The IN52 is for the second number, and IN53 is for the field which will give us the result. And this is a variable which I have declared. It is an indicator type variable. And what it will do, once I have validated all the fields, I will turn off this indicator, and based on that I will perform the calculations. So now this do while IN03 off. So you see in this program we have no anywhere not declared this IN03, but still we'll be able to use that because we have declared the display file in it. And once we declare a display file and compile that, whatever attributes or fields or indicators are being used in the display file, it will be used in the program as well. So do while n03 means until the function key F3 is pressed, it will continue to load the screen. It will not come out. And once I press the F3 key, it will come out. It will terminate the program. Then the second line, you can see there is a keyword exfmt rec01. Rec01 was the name of our record or the screen, and exfmt is a keyword which is basically write and read, combined write and read. So if we want to write our display file, and then if we want to take some inputs into that, we have to write exfmt and then the record format name. So what will happen once I have used this exfmt rec01, it will write that screen, and then it will wait for input from the user. Now if I press F10, you can see the screen is there. It has written the screen, and now it's waiting for the user to enter the input. Now let's see what happens if I enter the operation and the first number and don't press the second number. It will again run a subroutine, which is validate subroutine. So it will validate if everything is entered correctly or not. I'm again turning off the indicators in the beginning. Now the condition is if any of them the fields is blank, then it will throw error for that particular field. So put the number I haven't put the number 2. So it will go inside this condition and it will turn on the IN52 indicator, which is for the reverse image of that second number. And and again it will go to the do loop and it will do the exfmt, and you can see the reverse image is turned on. It was not in the, always turned on, but I have used a logic that when the field is blank, the reverse image will be turned on based on the indicator. And I have also given a error message so that the user knows what exactly is the error. Then I can press any other number, and again it will validate. It will try to see if everything is correct or not. And now everything is correct. It will not go inside any condition because all the fields we have entered. In the other, it is turning on IN53 indicator. That is the indicator for non-display. So when this indicator is on, the result field will be displayable. Initially it was not displayable, but now I have turned it on. And when next time it will do the exfmt or load the screen, the result field will be visible to you. First I'm doing the calculations. So the operation was addition. It did the addition and now loading the screen. So you can see the result field is now available for us to see, and it has performed the calculations. And if I press F3, so what will happen? It will run all the commands or flow. It will go inside the flow and it will come out automatically because the do loop was not satisfied. The IN03 was turned on, so it will not go inside the loop and the program will be terminated. So this was one basic display file program, and then I have one more display file program. I'll show you the display file first. So this, you can see I have two records in this. So we can consider this as a multi-format display file because we have two formats. One is a record format and then we have a window as well. And in the previous display file, we only had one screen. So we can call that as a single record display file. I'll show you the record. So this is just a program which will add data to a physical file. So there is an employee ID and there is an employee name and then an output field which will be used to give a error or something to the user. The function keys and everything, these are the labels. I'll again go to the program. I'll directly call this. There is no point in debugging it. The logic is same. So this is the first screen. So the employee ID is automatically generated from on the basis of the physical file. If I show you the data in my physical file, it has two records and with employee ID 1 and employee ID 2. And what I am doing in my program, I'm just incrementing the last employee ID with 1. So in my file, there were two records with employee ID 1 and 2. So I've incremented that and the next employee ID will be 3. If I don't put any name and press enter, the same thing will happen. The reverse image indicator will be turned on and a message will be thrown that we have to enter a valid name. I have given a F5 function key as well, you can see. So that will help us to refresh the screen. So I have pressed F5, so automatically the reverse image and the error went away. Now I have entered a name and pressed enter. So you can see what is happening. A window is getting popped up. This is the second record window type which is getting popped up, and it is asking us, are you sure you want to add or not? If I press N or press enter, so it will not do anything. But if I press Y and press enter, then it will say that record added successfully, and the employee ID will be automatically incremented. I'll debug this for you. I'll show you how to load the second screen. Yes, the same way we have declared a display file. I have also declared the physical file with the usage type as input and output because we are adding a record into that. Then a variable indicator type variable which will validate tell us that the field has been validated. Then again turning off the indicators. There is only one field, so only one indicator I have used for the reverse image. I am turning off that and turning off the declared indicator variable. Now this is the logic which will give us the incremented employee ID. So I'm reading the last record from the file and then incrementing it with 1 and saving that in our display file field D2EMP ID. So D2EMP ID will have the incremented value, and then we are doing a EXFMT record REC01. So it will write that screen and then it will wait for me to input. Let's say I have put in some value, press enter. It will first go to the validate subroutine, turn off all the indicators, and since the field is not blank, so it will not go inside any when condition, and this indicator I'm turning out on and at the end. This is just some program flow. So if it is validated, I'm clearing the error on that screen if there is some error populated, and then I'm running a subroutine that will add the record. Now, see in this subroutine, I have used a do while int12 is equal to off. So this int12 is not declared in the program. This is declared in the display file in the record level indicators, and that is being directly used inside a program because while compiling, all the attributes of display file are available to the program. So now this line means now for coming out of the second screen, we have to press F12, then only it will come out. Now EXFMT, doing a EXFMT on REC01 WDW. So the second screen will be pop up, and you can see this is the second screen. In debug it looks like this, but if you run it directly it will have the main screen at the back. And if I press Y and enter, so it will perform certain actions, and here it will write it, and the error message will be shown as record has been added successfully. Again it will do a EXFMT, increment the employee ID, and see the next employee ID has been incremented and the record has been added successfully. We can see this also in the file. So the record has been added successfully. Now this is how we can integrate the display files in our program. Now one thing I wanted to show you is that, so you see I have, while incrementing the value, I have used a display file field, and then inside that I have given the value of the file field, the physical file field. So one thing is that we can do that, we can inside a program control that, or we can directly use a employee we can directly use a physical file field inside on our display file. So the whatever the value of the field will be there in the physical file, it will also be generated on the display file. For that, we have to press F10 key on while designing the screen, and it will ask for certain options. I can write 4. Then I have to give the physical file name, the library of that physical file, and the record format, and press yes, and press enter. So you can see in the bottom, I can see both the fields of my physical file being able. Now I'm able to use that, and for that, wherever I want to use that, what I have to do, let's say I giving a label like enter employee ID, and here I can use ampersand sign, and if I want to use the employee ID I can write ampersand 1, and if I want to use the employee name I can use ampersand 2. So this is the directly how we can use a database field inside our display file. If you see the name, it will have the same name as the field in the in the physical file. And now we don't need to use this and then populate the value of the physical file field. We can directly read the file and it will be automatically populated on this screen. I think I have covered all the things. And okay, so there is was one more topic. If you go to option 8, select keywords and then indicator keywords. You see I had given CA03 and CA05. So CA means command attention, and there is one more thing, one more type we can give it as CF03, or whatever the function key want to use. We can either prefix it with CF or CA. So CA means command attention, and it does not, the meaning of that is it will not read the value from the screen. So let's say on any screen I have used 03 as CA03, and I have pressed that function key F3. So it will not read that value on whatever the value will be on screen. It will not read and give it to the program. It will just perform its action and whatever the action will be given. But if I use CF instead of that, so it has the ability to read that. CF means command function, and it will read the value from the screen basically. And the used case will be something like, let's suppose the program where I added data to the file. Let me call that. So if after entering a name there was one more function key, F6 is equal to add, and on pressing that function key F6, we will be able to add a record. So if that function key would have been declared as CA06, then this data will not have been read by the program, whatever the data was on the screen. But if that was being used as CF command function CF06, then this data would have been read and it will be able to add that data record to the file. So this is the difference. CA will directly perform its action and it is not bothered about the data, and the other one it is considering whatever the data we have entered on the screen. This is that. Now one last thing which we can discuss is, you can see by option 2 or by option 5 we can see the DDS of that display file. So DDS means data definition specification. So if I press 2, so this is an automatically generated DDS when we design the display file. In the beginning, the user will have to design it using the STRSDA or the 17 option. But once we get familiar, we can directly change everything from here. So if I try to change something, so this is the heading which was used in the program. I will put a dot in between, so it is now programmers.io. And one more thing I'll do, So this is a keyword default val. So this D2 option will have a default value as n. So if you remember the pop-up window, in the pop-up window while adding a record, the confirmation window, it had n automatically populated on the field. So either I can remove this or I can comment this like this, and now the display file has been compiled, and I compile the program and call it. So as you can see the programmers.io is not now changed. First it was programmers.io and now it is programmers.io. Then again the field is now not being populated with n by default. It will ask us for the input. So from directly using the option 2 after designing the file, we can make some changes if we want. But for that, we need to be familiar with whatever changes we want, and with the we need to be familiar with the DDS. So that was all for today. This was the overview of display files. You can try to create your own display files. And in the upcoming sessions, we'll have some advanced topics like subfile and Windows subfiles. Thank you, everyone. And if you have any questions or any doubts, you can let us know. You can type in the question and answers.
Yeah, hi everyone. So if anyone have questions, so you can put in the Q&A box so that Akshay can answer.
The benefit of this internship is quite simple. You are basically upgrading yourself, upskilling yourself, and that will help you in getting jobs faster, I would say. It does not give a guarantee, but it will, being a upskilled person, the jobs will get there is a benefit of getting jobs faster.
Okay, the question related to assignment, we will ping you in the Skype group so we can answer you there. And if you have a question related to this session, so you can put in the Q&A box.
So window, we have to create, like we created a record, we have to give the type as window, and then for the option to take yes or no, I have just given an input field, and that field I am using in the program to check whatever the user has entered. It's just a label, whether do you want to add or not, and then an input field.
Yeah, certificate will be provided for this internship at the end of at the end of this internship. Any more questions? Okay, we'll wait 2 more minutes, then we can wind up this session. Okay, I think there were no more questions, so we are good to wrap up this session. Thank you, everyone. Thank you, Akshay, and thank you, Nikhil.
Thank you, everyone.
Thank you, everyone.